Okay, and good afternoon all. Okay, now I will welcome you all for this session. In today's session, we are going to take the just we are going through the discussion will be there related to the how the design of a particular plastic part is done, and while doing the design of a plastic part, which general factors you have to take into consideration while making any design with the help of plastic parts, or while making any before manufacturing of any plastic component. First you should do the design, and after that you are going for the actual manufacturing. And how or which procedure you have to follow, or which factors you have to take into consideration while designing any kind of the plastic parts. There are general eight characteristics or 8 points you have to take into considerations. That 8 points we are going to discuss that. But before that, we will go through some our necessary points before starting any chapter. That points will be why means about the central idea of this chapter, means title of the chapter, then central idea of this chapter, then importance, why we are studying this chapter, and what will be the outcome of this chapter. Okay, then I will move towards the first slide of this design of the plastic parts. Okay, before starting this actual chapter, it is important to discuss related aspects related to your final theory examination. And compulsory one before, means they are asking one numerical questions. Okay, one numerical question. Based on this, they will provide some problems. One problem statement will be provided to you, and you have to design a plastic part. Okay, one standard procedure is there to design that particular plastic parts. Suppose they will ask you to design the they will give you some means problem statement consisting of dimensions of the chair, and for that chair you have to design some plastic bush. Okay, bush you have to design, and they will provide you all the dimensions related to that, how much weight that chair is going to carry, and depending on that, and you have to consider all the stress points, means how much stress will act depending on that weight, and according to that you have to do the design. Okay, you have to consider the design. Okay, and then which factors you have to consider, that we will discuss. First I will go through the syllabus content. Now in this chapter we are going to discuss related to the first very important points. We are going to discuss that are the tolerances and allowances. Okay, tolerances of molded plastic parts and allowances. For doing the any plastic part design, you have to provide this, some tolerances should be provided, some allowances should be provided there, that you have to then how much tolerances will be provided, how much that allowance will be provided depending on the material, that we are going to discuss in this chapter only. Then we are going to discuss related to the design of the corners, undercuts, ribs, then a wall of that particular plastic, then design of inserts, and along with this we are going to discuss related to the core material and mold material, and the concept of curing time. Okay, so the same points I have collected here, these are the contents of our chapter: tolerances, allowances, then design of different parts. Okay, design of corners, ribs, undercut, inserts, that we are going to discuss, and at the end we will discuss some materials, cores and mold materials. We are going to discuss it, and we are going to discuss the curing time concept. This we are going to learn in this chapter. Now what are the prerequisites? Okay, to for proper designing, or for better understanding of this design of plastic parts. First, the knowledge related to the plastic material, basic knowledge related to the type of the plastics, classification of that particular plastic materials and its properties is required. And you should have some basic knowledge related to the design. These are prerequisites. Knowledge related to the material and the knowledge related to the design is very important while doing the design for a particular part, and from which material you are going to manufacture it, and in which design you require it. And here, as we are going to discuss the design of the plastic parts, the basic knowledge related to the plastic material, it may be related to its composition, its properties, um, and that properties it will be there, its strength and how it is formed. That you have that knowledge is required, and the knowledge related to the design. These are the prerequisites for better understanding of this particular design of the plastic parts. And then, as the title is given, design of the plastic parts. Okay. Now, what is the meaning of the design? This will be divided in two parts: design and the material used is plastic. Okay. Here we want to discuss related to the design of the plastic part. Design is nothing but you are converting whichever idea or concept is in your mind, that you are converting into a drawing. Okay. Whichever means particular idea is there, or one concept is there related to that particular material, was here for the particular plastic material, that first you have to draw it. Okay, that will be termed as the design. And now this design, here we are going to do the design with respect to the plastic material. So for that, whichever considerations you have to take in, means design considerations will be there, that you have to take into considerations while considering that the plastic material. Okay. And in this chapter we are going to discuss the basic elements, that elements you have to take into consideration while designing any plastic part, and the standard design procedures will be there. Okay, to design, suppose you are considering means you want to decide the wall thickness of the plastic part, and some standard considerations are there. How much how much should be the minimum wall thickness. Okay. And then suppose you want to design, give the design for a rib. Okay. Some standard considerations are there. Okay. Related to the dimensions of that ribs, then related to the dimensions of the corners, some radius you have to provide. Okay, instead of sharp edges, some radius is provided there, and how much should be that radius is depending on the design. Okay. For that, some standard procedures and some standard dimensionings are there, that we are going to discuss in this design of the plastic parts. Okay. So this is the central idea of this chapter. Means central idea of the chapter means what we are going to study in this chapter. We are going to discuss what are the basic elements for proper designing of a plastic parts, and what is the exact procedure. Okay, suppose we want to design the ribs or corners, or some undercut is there, or a wall minimum, how should we decide the minimum wall thickness. Okay. Some standard procedures are there, and some standards are mentioned, and that all we will discuss in this chapter. Okay. And what is the importance of this chapter? If you study this chapter, then you will able to design a proper plastic part. Okay. A proper plastic parts, you will able to design that. A proper plastic, to design a proper plastic part, you should have knowledge related to the various design aspects and various design procedures. Okay, to design any plastic part that can be practically used. Okay. Which should satisfy all our needs and safety rules. To obtain that design, you should have basic knowledge related to how the designing is done, and what procedure you have to follow to design that particular parts using the plastic material. For understanding that all these things, you should study this chapter. This is the importance of this chapter. And then next is what will be the chapter outcome. Okay. After studying this chapter, you will be able to understand the basic elements, characteristics of the basic elements for proper plastic design, part design. Okay. Which basic elements you have to consider for designing any plastic parts, that you will be able to understand, and what standard procedure you have to follow to design any plastic part. Okay. For a particular application, which material you are going to use, and how the that particular design is done, that you will be able to understand. Okay, in short, I will tell you the basic elements required to design any plastic parts, and which procedure you have to follow while designing any plastic part, that you will be able to do after studying this chapter. That will be our objective, or this will be your the outcome of this chapter. And after this, we'll move towards this actual. Okay. Now here I have highlighted this. This is related to the introduction. Means here I have collected some basic points. 8 points I have collected. That 8 points you have to take into consideration while designing any plastic part. Okay, one by one we'll go through it. Okay, so this is our first slide. Okay, we will first. This is the little bit summary related to the points. Yeah, basic points you are going to consider, or the broader aspect. What is the broader aspect while considering design of any plastic part? Okay, while designing a plastic part for manufacturability involves many important factors. Okay, um, from all areas of part design. Okay, all areas of part design, then its tooling, and material selection, and its production. Okay, while designing the any plastic parts, you have to take into consideration that how that part should be designed, and which tooling and material, which material you are going to use to manufacture that particular part, plastic part, then which tools you are going to use. If suppose you have finalized one design, suppose you have finalized one design depending on your need or use, then after that you have to within your mind you have to take into consideration that which material you are going to use for manufacturing that particular design, and which tooling you are going to use, and which production method you are going to apply to manufacture that. Okay, this all these things you should keep into your mind before designing that particular part. Okay, whether that all the requirement is means whichever need is there, whether it is feasible, or you are just it is and in just your mind. Okay, that point you have to take into consideration. Whichever design you are thinking in your mind, it should be feasible. Feasible means it should be practically possible. Okay, in that you have to take into consideration that while designing any plastic part, whether the material is available to do that particular design, and whether the tooling is available, and whether the production is practically possible. This is the broader aspect before designing any plastic parts. These points you have to keep in your mind. Okay, then the next is while designing any plastic parts, you should consider the weight reduction. Okay, while designing any plastic parts, should consider that the weight of the, suppose you are manufacturing a plastic chair, then before designing that chair you have to take into consideration that that particular, it should satisfy all the criterias related to, means it should be having minimum possible weight. Then the there should be means minimum fabrication should be needed, or minimum assembly steps should be there. Whenever you are doing the design of any part, you should take into mind that minimum processes should be required to design that particular part. Minimum processes should be required, and it should be manufactured with minimum possible weight and with minimum possible cost. Okay, and that is mentioned here. Considering while designing any plastic part, you have to take into consideration that it should be possible to design that part with minimum weight, and then elimination of the fabrication processes or assembly steps, then improving the structural components, then reducing the cost. And you have to take into consideration that whichever product you are manufacturing or whichever design you are making after manufacturing that part, it should be very easily, it should be made very easily available to the consumer or that customer. Whichever product you are manufacturing, that should be you should be able to make it available very easily to the end users. Okay, these things you have to take into consideration. Okay, I will summarize this slide. While before designing any plastic part, you should take into consideration that availability of the material, or which material is required and whether that material is available, then which tooling you are going to use to give the available material the desired shape and size, and which process you are going to use to achieve this. Okay, and while doing this, you have to also consider that there should be minimum processes like fabrication or assembly processes should be very less, and whichever design you are doing, it should be possible with minimum weight and minimum cost. And your whichever end product you are manufacturing, it should be easily available to the end consumer. Okay, so these are the broader this is the broad aspect related to your design of any plastic part. Whenever you are starting any design, these broader aspects first you have to consider. Okay, this is the little bit broad aspect, and after this we will move towards some specific points consideration. Okay, now generally I have summarized this in 8 points you have to take into consideration while designing any part using the plastic material. Okay, this is the first I will tell you the name of these 8 factors we are going to consider. First factor will be related to the material consideration. Then related to the second factor will be related to the radius, or you can say that the corner design of the corner, how you are going to do the design of the, okay, the design of the corner. Then the wall thickness. Next point is you have to consider the wall thickness. Then some runner and gate arrangement we are using here. Related to that, we have to consider some points. And then we are going to provide some draft, how this draft is provided. Then some ribs, if suppose some ribs are present, then how you are going to design that ribs. And then mold shrinkage, how much shrinkage values you have to provide. Shrinkage will occur, and according to that, you have to provide some, or you have to consider some parameters. Then some special features. So, other than this 7 points, if any other requirement is there related to the uh, it will affect your final product or its characteristics, that you have to add here in the special features. In this way, these 8 points we are going to consider. Now we will look into it one by one. First we will start with the material consideration. Okay, this is related to the material consideration. Here the design word I have used for the plastic material. Okay, now while selecting any kind of the material, generally whenever we are choosing the material, we are all means little bit we are depending on the recommendations. Okay, whenever suppose you have decided to manufacture a chair, then from which material you are going to manufacture that chair, this manufacturing is done from, taking the recommendations from the some experts or from some suppliers. Okay, now after taking these recommendations, you have to consider the some points, whether that material is available in adequate amount and whether it is feasible economically. whether it is feasible to purchase that material and to do the necessary processing and to obtain the final product. Okay, these points you have to take into consideration while selecting that material. Some basic points other than this cost, these are some basic points. Okay, these two already I have explained, that cost and availability, and these are listed here. Other than this cost and availability, some other points like temperature, means chemical resistance, agency approvals, assemblies, finish, these you have to take into consideration. Temperature. Now, whenever you are selecting a material for manufacturing the plastic parts, that material will get subjected to particular processing, and then it may get subjected to some thermal stresses. Okay, so while selecting the particular material, you have to take into consideration that we are going to do the some processing on that raw material, then which kind of changes will occur there according to that, and whether it is sustainable to that changes. These points you have to take into consideration. This is related to the temperature, okay, of the raw material or the material. Then chemical resistance. Now, in this chemical resistance, you have to take into consideration these points. Means, what will be the effect of some external agents or external environment on your chosen material? These points you have to take into consideration. Okay, means if suppose you have manufactured the chair, then that chair, where you are using it, the surrounding environment, what will be the effect of the external? Suppose it is coming in contact with some gases, some solids, liquids. What will be the effect of that particular um, environment on your final product? Okay, that you have to take into considerations. And next point is agency approvals. Okay, now whenever you are selecting the materials, there are some restrictions related to the use of particular chemicals or some resins or some plastic materials from the government side. Okay, because these are some governmental and private standards for properties such as heat resistance and claimability, its electrical and mechanical capabilities. Some government has banned some use of some particular materials, that you have to check whether government is allowing the use of particular chemical or that particular resin. Okay, because there may be some emissions while doing the processing, there may be some emissions, or there may be some means some hazardous byproducts may be manufactured at the end. So you have to take into considerations whether that material is a, means whichever material you are selecting, whether it is possible to take the government approvals. Okay, and it should not be harmful. It should be in short, you can say that whichever material you are selecting, it should be eco-friendly. Then you have to take into consideration the assembly point. Means, suppose you have selected one material, whether it is possible to do the further processing like fabrication or assembly processing, like different welding processes or different joining processes, whether it is possible to do that on the material, so that you can manufacture the component. Instead of manufacturing larger components at one time, you can manufacture it in different parts, and you can join it later to get your desired large shaped or complex parts. Okay, so before that, you have to take into consideration that whether that particular material is suitable to perform the further joining processes. Then the finish, related to the finishing, whichever material you are using, you have to take into consideration its what means, you have to consider here aesthetic needs related to that particular material. At the What will be the appearance of your finished product? Okay, what will be the appearance of your finished product? This you have to consider here. Okay, means material's ability to produce desired finish, such as smoothness, glossiness. Okay, that you have to take into consideration. Then cost. whichever material is available, it's whatever, it should be feasible to use it in the actual production, and whichever processes are required to convert that material into desired product, it should be economical. And in that, you have to consider the tooling cost, labor cost, then other finishing cost may be there, then transportation cost may be there, that all things you have to consider here. And last thing is the availability, whether that material is available in abundant quantity or sufficient amount, so that you can manufacture it, that particular product, as per your need or as per the requirement from the consumer end. Okay, so these points you have to consider while selecting any kind of the material for doing the design. The first point you have to take into consideration while designing any part is selection of the material, or material selection you have to do. And while selecting the material for any plastic part design, you have to take these points into considerations. Okay, temperature, chemical resistance, then agency approvals, then assembly, finish, cost, and availability. Okay, this is the first point that you have to take into consideration first, and this is very important point. Then next is the radius. The second point is the radius. If you are having any query, I'll take a pause for 1 minute here. You can ask me or you can put that in the chat box. Okay, so I will consider that you are not having any query till this point. So next point is the radius. Okay, while designing any plastic part, okay, for this each point we are having brief discussion later. Okay, we are going to do the brief discussion or all these points, the design of the radius or corners, design then minimum wall thickness, design of undercuts, all these points we are having some definite standards or definite procedure we have to follow, that we are going to discuss in the coming sessions. So in today's session, just I am summarizing all that correct parts here in one lecture. Okay, in that, after selecting the material, the next part is the radius. Okay, now while designing or while providing the radius. Okay, why the first you should understand why there is necessity to provide some radius or some corner should be provided. Okay, instead of the sharp edges at the you can say that one corner you have to provide. Why it is necessary to provide it? Okay, it is necessary to provide this radius to avoid these sharp edges. And what is the you can say that benefit of avoiding the sharp edges? Whenever sharp edges are there, high stresses will be there. Okay, due to the sharp edges at that particular sharp edge point, stress will be more. Okay, whenever sharp edges are there, stress will be more, and the possibility of the breakage of the particular component or part due to that sharp edges is more. To avoid this, to avoid the high stress points and to avoid the breakage of that particular component, we are providing a radius, or you can say that we are providing the corners. Okay, just in simple way, corners are provided. Now, how much radius should be provided? Some basic thumb rules you have to follow in the design. Some thumb rules are there. Now, whichever minimum part thickness you have taken, depending on that minimum part thickness, this radius will be provided. Okay, while providing that, suppose you have provided some thickness, uh, and according to that thickness only you have to provide the radius. Okay, and one thumb rule is there, that radius should be zero point 0.9 times the thickness, uh, and a maximum you can take up to 1.2 times the thickness. Okay, this is the thumb rule. Okay, the basic point is, here you have to consider that why we want to, why radius should be provided, and how much it should be provided. Okay, why it is provided? Whenever sharp edges are there, high stresses will be created, and that particular product may get damaged due to that sharp edges. To avoid this, we have to provide the radius. Okay, radius or some corners are provided, and while selecting this radius should be zero point 0.9 times to 1.2 times the wall thickness selected. Whichever wall thickness you have selected, depending on that wall thickness only the radius is provided. Okay, the next point you have to consider while designing any plastic part is the wall thickness. Okay, now, while designing any plastic parts, as far as possible, it is possible, you have to consider the minimum wall thickness. Wall thickness should be minimum. Now, why wall thickness should be minimum? Now, there is in short, I will explain it. There is one relationship between the cooling time and the wall thickness. Okay, cooling time is directly proportional to square of the wall thickness. Okay, when the wall thickness is more, cooling time required will be more. Okay, cooling time required will be more, and when cooling time is more, you can say that it will be not economical to do the manufacturing. Whenever large cooling time is there, it takes more time, that is uneconomical to do the mass production. Okay, and another is, sometimes that suppose large thickness or more thickness is there, then shrinkage will be more. Shrinkage will be more. So that's why there is a basic rule that the as far as a possible wall thickness should be minimum. Wall thickness should be minimum, and it should be uniform throughout. It should be uniform throughout. Okay, now, why it is necessary that it should be uniform? Whenever that wall thickness is uniform throughout, you will get the defect-free product. If wall thickness is non-uniform, okay, inconsistent wall thickness, that is explained in this point. If wall thickness is inconsistent, then the flow will be also inconsistent. Then it will result in some defects. Okay, it may result in some kind of defects. To avoid that, you have to consider here the wall thickness should be minimum and it should be uniform throughout the part. It should be minimum and it should be uniform throughout the part. Okay, you can go through this designing your part so that wall thickness is consistent. It can help you to may avoid many part defects that may occur during the manufacturing. Okay, whenever wall thickness is minimum and uniform, you will be able to avoid many defects that will occur during the manufacturing. Okay. And what exactly occurs that is explained in these 2 points. Whenever you are having inconsistent thickness for that particular part, then material, whichever molten plastic material is there, it will first flow in the thicker side. Okay, first it will flow in the thicker side, and whichever thin thickness area is there, it will not get properly filled. It will not get properly filled. That's why it may result in improper product or defective product. Okay, that's why wall thickness should be minimum. Wall thickness should be minimum and it should be uniform throughout. Okay, and after considering this wall thickness, the next point you have to take into consideration is uh, gate location. Okay, gate location. Now here, this gates arrangement. Okay, for that particular plastic material, we are melting it and it is allowed to flow into the mold. Okay, that and it is flowing into the mold through some runner and gate arrangement. Okay, that you have to choose that proper design of the runner and gate you have to choose, because depending on that runner at gate only, they will control the flow of that resin is nothing but your plastic material, and depending on that flow, your final product will be obtained. Okay, because the type of that gate and runner, it will only decide the quality of that flow, and at the end it will determine the quality of your product. That's why this gate location and its design should be properly done, because through this gate and runner arrangement only, that molten plastic material or that resin will flow into the mold. Okay, and accordingly you will get the proper plastic part. And next is the draft, design of the draft. Now what is before understanding how much draft should be provided, what is the meaning of draft? Okay, draft is nothing but the amount of taper. Draft is nothing but amount of taper on the vertical walls of the plastic parts. Okay, some taper, instead of manufacturing exact vertical walls of that particular plastic part, we are providing some taper. Why this taper is provided? Now after completing the solidification or cooling process, that plastic part should be removed from that mold cavity, and for proper removal of that mold particular plastic part from the mold cavity, some taper is provided, so that at the end of solidification or cooling, part can be easily injected from the mold cavity. Okay, so that it will avoid the damage to the part while removing it from the mold cavity. And generally this draft angle is 1 to 2 degrees Celsius draft angle we are providing. Okay, for safe removal of the plastic part from the mold cavity, some taper is provided on the vertical wall of that plastic part. It is termed as a draft, and generally we are providing 1 to 2 degree draft. Okay, so and this draft is selected depending on some specifications or depending on your part design. And after this, next is the some aspects you have to consider related to the ribs. If you are having any query, you can ask me. Okay. If you are not having any query, we will move towards this last 3 points are remained here. The design of ribs, then mold shrinkage, and some extra special features. Okay. Now, why the it is necessary to provide the ribs? Okay, in the previous points we have considered that wall thickness should be minimum as far as possible. Wall thickness should be minimum, or it should be less, and it should be uniform throughout. And now, as you are providing minimum wall thickness, sometimes it will result in poor strength of that particular plastic part. Now, to give the necessary or required strength to that particular plastic parts, ribs are provided. Inclusion of ribs is necessary to make that particular thin plastic part, or to provide that particular plastic part with the desired strength. Ribs or support is provided, that is termed as the ribs. Now, generally, depending on the material used, this rib thickness is decided, and it is decided depending on that material and depending on the wall thickness. And generally, this rib thickness is provided 50% or 70% of the wall thickness. 50% or 70% of the wall thickness. Okay, it will provide the strength, and also it will avoid the sinking. Okay, it will avoid the sinking also, or some sink marks are avoided. Okay, and then after this ribs design, mold shrinkage. Okay, mold shrinkage. Now, you have to consider this point that 20% okay, 20% shrinkage will occur. The shrinkage that occurs during the plastic part molding process can be 20%. Okay, whenever you are using the crystalline materials or semi-crystalline materials, and then more thermal shrinkage will be there. And when amorphous material is used, less shrinkage will be there. Now, to avoid this molding shrinkage issues, the some basic specific points you have to consider while doing the mold design. Okay, just you have to add this the formulation means it is related to the composition of the material. As far as possible, you have to um, take the composition or material that it should provide a lesser shrinkage. Okay, it should provide a lesser shrinkage. Then you have to adjust the mold design. Okay, mold design dimensions are adjusted based on the expected shrinkage. Okay, depending on the expected shrinkage only that mold is designed. And you have to optimize the process parameters like molding temperature, melt temperature, injection speed, or some pressure or cooling time. Okay, depending on the shrinkage also, you can by considering the possible shrinkage, you have to select the material. Then you have to design the mold by considering the possible shrinkage. And material you have to select. The adjust the formulation means selection of the material in such a way that shrinkage should be minimum. Then design of the mold should be done in such a way that by considering some percentage, suppose some 10% shrinkage will occur. According to that only, you have to design the mold, and you have to choose the proper processing parameters so that the shrinkage will be less. Okay, that parameters may be your molding temperature, melt temperature, or some parameters related to your process, like it may be pressure or process time or speed or cooling time. Okay, depending on this, uh, depending on the amount of shrinkage only, you have to do the optimization of that process so that shrinkage will be minimum. And next, this is the last point. Now, depending on your need, if suppose you have added some special features like some holes, undercuts, or some shoulders. Okay. Now, depending on that, some side action, you have to make the changes. Okay. Depend. Suppose you have provided some holes or undercuts, some ribs, extra shoulders are provided, and depending on that, you have to make the changes in your design. Okay. Then plastic parts should be designed so that mold tool open and eject the part easily, and when part is released, okay, when part is released, two sides of an injection mold separate in opposite direction. Means this some special features you have to take into consideration, that whenever it should provide you easy ejection of the component from that mold cavity, and if you have needed some extra features in your plastic part, according to that some design changes should be done. Okay, so in this way you have to consider these 8 points while doing the design of the plastic parts. Okay. Okay, I will summarize, or I will finish this session here only. Okay, in this session, we have discussed that the which broader points you have to take into consideration while designing any plastic parts, like which material you are going to select, which tools are required, then which manufacturing process or processing method you are going to take to give the desired shape and size to the raw material. Then how much you will do the reduction in the, how much reduction in the cost or how much reduction in the weight of that product is possible, and how you are going to eliminate the extra processes, and how easily that product should be made available to the end user. These points you have to consider before designing. These are the broader aspects, and some necessary while designing you have to consider this material characteristics. Initially you have to consider the material characteristics. Means what are the properties of the materials related to its cost, availability, in finishing, then assembly, chemical resistance, temperatures, agency approvals. Then some parts you have some factors like radius, how much radius should be provided to avoid high stress points and breakage of the part. Radius should be provided. Minimum wall thickness should be there. Minimum wall thickness should be there, and it should be uniform throughout. Then the runner and gate location and its design to ensure the proper flow into the mold cavity. Proper runner and gate design is required. And draft should be provided for proper ejection of the component from the mold cavity by providing some taper. The taper should be provided on the vertical wall of the plastic parts. And ribs is provided as minimum wall thickness is used, minimum and uniform wall thickness is used for designing the plastic parts. To give the necessary strength required, ribs should be provided, and it should be 50, its thickness should be 50 to 70% of the wall thickness. And then by considering the um, shrinkage which may occur, you have to consider the formulation of that particular plastic material, then mold design, and you have to optimize the processing parameters like molding temperature, melt temperature, and some factors related to the process like its speed, pressure used, time required, and cooling time required. And some according to the spatial features, you have to do the modification in the design. Okay, so in this way we have considered various points while that you have to consider while designing a plastic pond. Okay, uh, so thank you for attending this session. I will stop here. From next session we will look one by one how the wall thickness is selected, and what is the effect of it, and what standards you have to follow while doing it. Okay. Thank you for attending this session. You can put your roll number for your attendance purpose in the chat box.